Alright, so now we're going to talk about section 7.3, using the central limit theorem, okay? When to use it. And it's based on the question that they are asking. I've got two examples we're going to go through. How we compute things is going to be exactly how we did it in the previous section. We're going to be using normal CDF. We have to use the mean that they give us. We have to find the standard deviation. But then after the end of my two examples, I ask a extra question, and we're going to compare the questions and what they're asking to what I ask and see what the difference is. Okay? Now it says, if you're reading my notes, it says when to use the central limit theorem. Use the central limit theorem if you are when you are being asked about the probability of the mean or a probability of a proportion of a sample. So for instance, I would say, what if I were to sample 100 people, what is the probability that my sample will have whatever average or proportion that we want to know, okay? Now, the second one says, if you are being asked about the probability of individual values in a sample, do not use the central limit theorem. Use the distribution of the random sample, okay? So that would be like, what is the probability that, I didn't give a scenario. Let's say the average age of CLC students. What is the probability that someone has an age less than 22 years old? Okay. See, here I asked about someone, whereas the previous question I asked, I wanted to know what is the probability that the sample had an average, not an individual having a certain value within the range of our sampling distribution. So let's go ahead. This section will go by really quick. Let's go ahead and look at this example. It says, in a study involving stress, is conducted among students on a college campus. The stress scores follow a uniform distribution with the lowest stress score equaling 1. So our stress scores follow a uniform distribution with the lowest score being 1. And then the highest score being, I think it's 5. Let's see, equal to 5. It is 5. Now it says, using a sample of 75 students, so N here is 75, find the probability that the average test score, average stress score for the 75 students is less than 2. Okay, I am being asked about the average, the probability that the average stress score for this 75 students is less than 2. I am not asking what is the probability that a student has a stress score somewhere within this range. Okay, now we want to use the central limit theorem. Our N here is greater than 30, so that's good. Now I need to find the mean of our sampling distribution. Well, this is going to be equal to the mean of the uniform distribution. So that means I need to find the mean of the uniform distribution. If you recall, the average of the uniform distribution is A plus B divided by 2. 1 plus 5 divided by 2. Here's my A, here's my B. That's 6 divided by 2, or in other words, 3. So we've got the mean of our sampling distribution equaling 3. Now what we need to do is we need to find the standard deviation of the sampling distribution. Well, this is going to be equal to the standard deviation of the uniform distribution divided by the square root of 75. So if you recall, the standard deviation for a uniform distribution was b minus a divided by the square root of 12. Well, this is equal to 5 minus 1 divided by the square root of 12. And then we're just going to punch this in on the calculator to get an actual number. 5 minus 1 is 4, so 4 divided by the square root of 12. This is going to give me 1.154. 1.154. So now we've got the standard deviation of our sampling distribution. It's 1.154 divided by the square root of 75. Okay? So here I found the standard deviation of the uniform distribution. I needed this number to plug it in to here to find the standard deviation of my sampling distribution. Okay? This square root divided by 12, this has nothing to do with sample size. This is just the formula that we had in chapter 5 for the uniform distribution standard deviation. So now if we calculate this number, so divide this number by square root of 75, and we're going to get 0.133, and it repeats. Okay. So now what we can say, although our distribution for our random variable is uniform, our sampling distribution is approximately normal with a mean of 3 and a standard deviation of 0.133. So now if we read the question one more time, find the probability that the average test score for the 75 students is less than 2. So if I draw you a picture, right here is mu of x bar, right here's, 3. We want to see, do they have a stress score less than 2? So right here would be 2, less than 2 would be all this area over there. So we're going to use normal CDF. Our lower bound is some really large negative number, negative 100 works here, comma, our upper bound is 2, comma, our standard deviation is 3, one more comma, our standard deviation, our average is 3, our mean is 3, our standard deviation is 0.133, and then I just plug this in on the calculator again. So second, vars, go to normal CDF, negative 100, 2, 3.133, paste, and then hit enter. Oof. Comes out to be about, my calculator outputted 0. So these 75 students, if you were to find their average, well, about 0% of the time, you're going to find the average stress score less than 2 is going to be about 0. Okay, these are some stressful students, I guess. You guys are in college. I was in college. I know how stressful it is. But okay, let's look at the next question. If you're looking at my notes, I said there's an extra question on there. What is the probability that a student has a stress score of, it says of 3.5, it should say less than 3.5, okay? So look at the difference between the question that I'm asking there and the original question. The original question says find the probability that the average test score, meaning these 75 students, the average of their stress score was less than 2. Here, I'm asking what is the probability that a single student has a stress score of less than 3.5 or less than 2. There's a difference here. When you're asking about an individual from a sample, you're going to use the original distribution. Okay, so if we wanted to really answer this question, for find the probability that x is less than 3.5, here's our normal distribution from 1 to 5. 3.5 would be somewhere right there, and we'd have to find the area, we'd have to find f of x. So when you are being asked about an individual value, the probability of an individual value, you're going to use the distribution that they gave you, okay? But when you are being asked to find the probability of a mean or of a proportion, then you will be using the central limit theorem for that. Now here's a question, the next question, that hopefully maybe all of us can relate to. It says, according to the IRS, Internal Revenue Service, or the IRS, the average length of time for an individual to complete IRS Forms 1040 is 10.53 hours. So the average is 10.53 hours. Without any attached schedules. Okay, I don't know what that means. But anyways, the distribution is unknown. We don't know what the distribution looks like. Okay, so if we were to be asked about finding individual values, right now we couldn't do it. Okay, however, we're not asked that. It says the distribution is unknown. Let's assume that the standard deviation for the distribution is 2 hours. Now, suppose that we randomly sample 36 taxpayers. So our n here is 36. Now, we want to find the probability that the average amount of time it takes to complete these IRS forms is less than 10 hours. Okay? Well, mu of x bar, since we don't know what the distribution is, we don't have to calculate the average. They already told us the average. Whereas in the last problem, they didn't tell us, or they didn't give us explicitly the average. They gave us the distribution. They told us the parameters for the distribution. We had to find the average ourselves. If they would have said this problem has a binomial distribution, we would have had to take n and times it by p. And that's what would go right there, okay? You always use the mean for that specific distribution. This one, they didn't tell us what the distribution was, but they gave us the mean. We also have to find the standard deviation of the sampling distribution. The standard deviation of the sampling distribution is whatever the standard deviation is for the original random variable divided by the square root of sample size. Well, that's 2 over 6, which is 0.333. It repeats. Okay. So now we could say that our sampling distribution is approximately normal, with an average of 10.53 hours and a standard deviation of 0.333 hours. And we want to find that the probability that the average is less than 10 hours. Okay? So now we just do what we've been doing. Normal CDF. Normal CDF. Now, less than 10, if I were to draw a picture, right there's the mean. This is 10.53, so 10 is somewhere over here. Less than 10 is somewhere over there. So normal CDF, negative 100, comma 10, comma 10.53, so lower bound, upper bound, mean. Now, standard deviation. We're going to use this number right here. We do not have to divide it by the square root of 36, our n, because we already did that. Now we just have to input this on the calculator, and we've got our answer. So, let's see. Normal CDF, negative 100, 10, 10.53, and 0.333. Paste 0.0557. So what this is saying is that if I pull samples of size 36 from this distribution, there's a 5% chance that the average of that distribution is less than 10 hours. That's what this number is saying down here. I've got a 5% chance that if I choose one of my samples, the average will be less than 10 hours to complete these IRS forms. Okay, now if we look at the extra question, it says, what is the probability that an individual takes less than 9 hours to complete the IRS form? Well, we're asking about a specific individual. So we would not use the central limit theorem here. We only use the central limit theorem when we're talking about the sample averages, the sample means, or proportions. But for an individual, we would have to use just whatever the distribution was, okay? Just like we were doing chapter 6. When you're being asked about a certain individual, you do what we did in chapter 6. When you're asked about the average mean or average proportion, so of the sampling distributions, you use chapter 7, central limit theorem, okay? So that's the difference here. Now this is the end of 7.3. If you look at your homework, it's chapter 6 and chapter 7. I know you guys already took the chapter 6 test. However, there's questions there that test your ability to differentiate between when to use the central limit theorem and when not to use the central limit theorem. So, yeah, if you have any questions, let me know.